Okay guys, today we're talking about scientific notation. Scientific notation is a way to express really large or really small numbers, and we're talking about distances in space or very, very small particles. There are three components to writing a number in scientific notation or writing a number in standard form from scientific notation. The first part is the trickiest. First part is a number from 1 up to 10, but not including 10. And that's the tricky one. I'm going to say it again. So I'm looking for a number from 1 up to 10, but not including the number 10. And the example I used was 9 and 99 hundredths, and with the repeating sign on that. So basically 9 with as many nines after the decimal point as you could go up to 10, but I'm not going to include 10. The second part is I'm going to multiply that number by 10, and then the third component is on that 10 I'm going to have a negative or a positive exponent. The negative numbers are going to represent very large numbers. The negative numbers are going to represent very small numbers. The positive numbers are going to represent very large ones. So if you see a negative number, you're going to think decimal. If you see a positive exponent, you're going to think a very large place value number. So let me get some of this out of the way. We'll do a couple practice problems. Okay, let's look at the number 7,800,000,000. It's not too large of a number when we're considering things like space, but it's still a relatively large number. There's an easier way to write this, and if you were a scientist or a mathematician, you wouldn't want to write all these zeros all the time because there's a chance you might leave one off. It leads to errors, which could be major problems. So the first thing I'm looking for is I need a number from 1 to 10, but not including 10. And the way you get that is you look at the first numbers. I've got 7 and I've got an 8. And I'm going to make that 7 and 8/10. I'm not changing anything, I'm not adding anything. I'm just looking at my first digit, and if that first digit falls between 1 and 10, I'm going to put the decimal to the right of it. Now, I put the decimal between the 7 and the 8, and I'm going to count the spaces all the way to the end. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's where the decimal would be. So I move my decimal 9 places. I'm multiplying by 10, and my exponent is going to be 9. Move the decimal 9 places. I started here 1, 2, 3, 4, 5, 6, 7, 8, 9. That's all you have to do. These two numbers represent the exact same thing. 7,800,000,000 is the same thing as 7 and 8/10 times 10 to the 9th power. Well, let's look at it this way. Let's say you have one in scientific notation, and we want to figure out how to get it into standard form. So I've got my number, 3 and 4/10 is there, and that's where the decimal will be. I'm going to move that decimal 7 places to the right because I know that whenever I see a positive exponent, this is a very large number. 1, 2, 3, 4, 5, 6, 7. And everywhere one of these little dips is, I'm going to put a 0 there. And I'm going to go back and double check, make sure. 1, 2, 3, 4, 5, 6, 7. And now I'll go back and I'll add my commas. Normal. And I end up with 34 million. And that's the way you do positive exponents. Negative exponents are a little bit different. Before I go on, I want to show you one thing though. It's neither positive nor negative. If I have something that looks like this, whoops, marker's fading out, 3 and 4/10 times 10 to the 0 power. Anytime you see anything to the 0 power, your answer is the number you started with. I'm not moving the decimal any places. So 3 and 4/10 times 10 to the 0 power is just 3 and 4/10. So it's not such a big deal here because we only have one decimal. But if you had a very large number with multiple decimals at the end, it may be easier to write it as this than it would be any other way. Now, negative exponents are a little bit different. Let's just say I was given let's see, 57 10 millionths, I believe. Tenths, hundredths, thousandths, millionths, 10 millionths. Yes, 57 10 millionths. The way this is going to be written, I need a number to begin with. I need a number between 1 and 10, not including 10. So I'm going to put my decimal right there. I'm not going to change the order of the numbers or anything like that. So 5 and 7 tenths is definitely a number that is between 1 and 10. You wouldn't want it before, because then you would have 57 hundredths. That's not between 1 and 10. That's less than 1. And you wouldn't want it after, because that's 57. Doesn't help you. So between the 5 and the 7, and I'm going to multiply it by 10. And let's see how many places I move my decimal. 1, 2, 3, 4, 5 is where I put it. So this is 5 and 7 tenths times 10 to the negative 5, negative fifth power. And the reason I know it's a negative fifth power is because it started as a decimal, a very small decimal. And that lets anybody know that your answer is going to be a very small decimal. Because if I just put 5 and 7 tenths to the fifth power, I would go 1, 2, 3, 4, 5. 570,000 is a lot. 570,000 is a lot more than 57 10 millionths. You're thinking about the difference of very small measurements to a very large number. So you have to be very precise, very accurate. You have to make sure that you have negative when you're talking about a decimal. It's not something that you can just leave out and say, oh, I forgot it, that's what I really meant. If you're talking about a really small number, you have to have that negative exponent. If you wanted to go from scientific notation, if you wanted to go from scientific notation into a standard number, you would write 3 and 69 hundredths on the right, because you're going to have zeros in front of it. And you're going to go 4 places to the left from where your decimal is. Not 4 places from the end of the number, in the middle, or at the end of it. Wherever your decimal is, you're going to move that however many places the exponent tells you. 1, 2, 3, 4. Decimal's going to go there. I'm going to put a 0 into each one of these little dips or valleys, and this is going to be my answer. 369 10 millionths, I believe. Yes. So that's going to be your answer for that. This is a little bit tough. You do want to take your time, count the places, and it definitely helps to add these little dips and valleys, peaks and valleys, to where you're going to put zeros in there. Go back and double check your answer when you get finished. It doesn't take long just to count the spots, just to make sure. Precision is very important in this, and when we think about the difference between 1 0 or 1 place value, if it's a very large number, it can mean a lot of difference. The difference between a million and 100,000 is a whole lot. So you want to be very precise, and we'll practice this more in class.